Moment. Yes, yes. Hello, friends. Welcome to Java channel with Sendil, talking about microservices with JHipster. Hello, Sendil. Please introduce yourself.
Yeah. Hello. Hi, everyone. This is Sendil here. Hola. Am I speaking it right? Hi. This is my very first online meetup. So bear with me if I made some mistake, but let's go. So yeah. So today we're going to see about microservices with JHipster. And I am Sendil. I'm basically from southern part of India. And currently I'm living in the Amsterdam or Netherlands. And I'm a senior software engineer, and I'm also a team member at JHipster. And feel free to ask any questions in the middle of the presentation or when we are doing demo. Feel free to ask. Yep. So what we're going to see today, today's agenda, we'll start with why microservices, of course, the basic question. JHipster, what you can do with it, what is the architecture that we are building, and finish off with JDL. So why microservices? Monoliths are simple, right? Monolithic architecture is very simple. You can create your application much more faster, and it's simple and easy. Also, bootstrapping your monolithic application is much more faster than compared with building an entire microservices suite. So it is much more simple. It is faster to build. But the problem is, in terms of monolith, you're tied to one little stack. So you have to live with that stack. If you're starting with a particular technology, a particular language, a particular architecture, you're stuck with that architecture forever, and you cannot easily move away from it. And it also reduces scalability. So when your company is expanding a lot, you have to put more and more instances. You cannot scale that very well. So monolith reduces the scalability of your application. On the other hand, microservices are scalable. You can have this individual chunks of services, and all those services are scalable. You can grow them as you want. You can make them work in whatever direction you want to. You can horizontally scale them, you can vertically scale them, and do whatever you have to do for microservices. And on the other hand, each of those services is an isolated entity. If they are not isolated, they are not microservices. So they all are isolated entities, which means you can use various technologies for those things. And every little bit of services can be written in any language that you want to, can have any kind of architecture inside. And it also, you can respond faster. So imagine a scenario where you have huge application architecture. You want to respond faster. You want to take down a single application or upgrade a single application. It's much more easier in terms of microservices because not everything lives in a single bundle. Everything lives in isolated chunks. So you can just go ahead and remove that or upgrade that and do those things, which means you can respond much more faster than in the world of monoliths. And one of the cool features with microservices is fault isolation. Suppose any of the node goes down, you can just remove that node completely, and you can isolate that node, and then your application should work autonomously without any problem. And you can also scale your applications as and what you want. Suppose there is a segment of application, you want to scale it for a bigger audience, you can scale it very good. And you can also scale down applications such that only 3 instances are running, or you can go up to 1,000 instances and 1,000 instances running. So granular scaling is also possible in the world of microservices. They're all good things, right? But in terms of monoliths, the problem of everything is what the code that you have written. So all the problem lies inside the chunk where you have written your code. And many times the problem is basically because of the wrong code that has been written inside it. But in the world of microservices, the problem not only lies inside your application, but it lies between your application. Here, you're living on networks, and you cannot have 100% reliability on the networking. And that causes a major problem in the world of microservices. So it is always better to think this before going to microservices world, because the problem is not 100% fixable and it's not 100% reliable. So you're going to fix something that is not reliable, and that is something that you have to take into consideration before moving to the world of microservices. So consider that you have a very simple application. You have a store application. Consider the store as a gateway through which all your clients will come and interact with your services. And you have these three small services, which is notification, product, and invoice. It's a classic store, right? So all of them is an individual service. You might have written them in a different language, or you might have written them in a different architecture or something or other. But so if you have to put this application into production, what you have to do, you have your gateway through which all the services enter, and you have all those three small microservices. So obviously, they have to talk with each other in order to make that conversation happen. And also, you can add more instances. You can run multiple services together. So in order to do that stuff, obviously, you have to add a load balancer on top of it. We have load balancer, everything will connect, even if you have multiple instances. Cool, we can add load balancer. All the applications in the monolith world will also have a load balancer. That's fine, right? And so all these services will have different IP address, or consider they are a Docker instance that are running inside your network. You need to connect to those services, but there can be multiple versions of those services. So what you have to do, you have to have something called a service registry. And the sole job of service registry is to register all the services that are running. And whenever a service wants to connect with other service, they go to service registry and say, hey, I want to go and talk with the product service. And service registry looks up in the registry where the product is there, what is the DNS or IP address, and then it connects to that IP address. It says, okay, go here and talk with that person. So that's how the entire connection works. So you need to have a single service which holds. You can do this in a multiple different ways, but for example here, let's have a single service that kind of holds all those information, and it helps to connect between the services. So all these services should connect through the service discovery and then talk with each other. That's how it's going to happen. And then you need to monitor the services. So you need some kind of dashboards to monitor all those services. And you have to trace those services. You have to find where the problem is, what are the things that I have to do. So you have to have centralized tracking. You have to debug them and also measure what is happening. So these kind of measurements is mandatory in the world of microservices if you're doing it correct. And if you want to understand how different services work. And that is something that we have to take into consideration. Next, all the services, when they talk with themselves, you have to have an authorization stuff inside it. So you have to authenticate and authorize all the requests that is going through the services. So you need some kind of security mechanism. And this security mechanism, you need it configurable such that sometime down the line, if you want to change the security, how you allow access to certain services, you have to ensure that security mechanisms is enabled here. And you have to have some timing device. For example, if store is trying to connect invoice, and invoice is continuously waiting for something to respond, and your service should know that it has to time out at certain point of time. If it goes beyond that time, it has to automatically cancel the request and then retry the request. If you're not doing that, then that particular instance will queue a lot of incoming requests, and all those incoming requests will be there, and it will never be executed, and you will have like cascading failures. So invoice gets failed, and then the other service will get failed, and then the service which depends on that will get failed. So you have this kind of scenario. So in order to remove that, you need something like a clock here, or a timeout specialist, timeout service here, which kind of times out after some time when you make a request. And of course, if the timeout is happening, if there is some problem, you want to retry the request, you cannot ask your user to retry every now and then. So you need to have some mechanism in which the retry happens automatically. And finally, you have to have a centralized configuration through which you can go and change whatever is happening inside your application. So these are the main parts of simple microservices application that you need. It's not really only these three services that you're living with. Now you have a whole bunch of highly available services which you have to work with. And finally, you also have something like hardware and container, where you have to think about how you're going to manage the hardware. What are the virtualizations that you're going to do? What is an operating system? What are the softwares that you're going to install? Of course, you have tools like Kubernetes or Docker to handle those things, but you have to think that through. And finally, you also have the heart there, which basically tells you the health of the application. You have to constantly monitor the health of the application throughout this entire stuff. So all this entire stuff for just 3 applications, and it's going to get messy when your services scale automatically. And you have to maintain something always. So there are like a lot of highly available services that you have to maintain. So which is a problem, right? So that's where your microservices get more and more complicated. You have tools like Kubernetes and Istio that kind of helps you to release those things, help you with those things, but still you have to think through this entire process. So I would say like when you're going into the world of microservices, it's always better to start with monoliths, experiment your feature, go faster to the market, try something better. And once you get hold of it, once your customer base increases, once you have a lot of requests and you especially want to go into microservices, then think before going into there and then try to do it in a correct way, try to architect in a correct way such that it makes it easier for you to live in the microservices world. And for anyone who is thinking of moving into microservices, have a look at this post by Kelsey Hightower, Monolith of the Future. He clearly explains why monolith is good and what we have done wrong in microservices. And if you have to do a correct microservices, what we have to do. And this is very well expressed in this post. So have a look at it. I will also share the slides after the presentation, where this post will have the link. Fine. We move to the next part of the presentation, JHipster. Any questions so far? Anybody has any questions? Oh, is it good to go? Great. Okay. So let's move to JHipster. So what is JHipster? Does anybody of you use JHipster before? A few people might have heard about it. Great. Yeah, it's very difficult to get a feedback on a live session. I know that. Let's move forward, hopefully. So JHipster is a development platform which helps you to generate, develop, deploy your modern applications. So that is something at a very high level. You can see like it's kind of a application generator, but it not only generates an application for you, but it also helps you to develop and deploy those applications. And that is really a good thing. So what does JHipster provides? What are the options that you have? So you can generate an Angular, React, or Vue-based front end. And of course, the front end is written in TypeScript. So you can choose between any one of those client-side applications. And everything is built with Webpack and as a bundler tool for the front end, the client side. And at the back end or the server side, you can choose between Java and Kotlin. And the application or the framework that we're using is Spring. So it is entirely based on Spring Boot. And at this moment, we have like a .NET-based generator or a Node.js-based generator. We also have Quarkus and Micronaut in the works that is happening. But right now, our main generator is based on Spring Boot. And then you can choose between various caching mechanisms. So applications today require a lot of caching. So you can choose between InfiniSpan, Memcache, Hasselcache, and Redis. So you can choose any of those caching mechanisms that you want in your application. We also provide an ELK out of the box. So you can also configure your application to have Elasticsearch, Logstash, and Kibana for debugging all those services. This is especially very helpful in the microservices world. And of course, you can choose between Maven and Gradle for your build tool. And for database, we have support for multiple database. This is only a small list that we have here, but we have a huge set of databases, all major SQL related database or a NoSQL database like MongoDB, Cassandra. And also we have support for Neo4j, which is recently added. You should check it out. The recent version 6.9.4 has Neo4j support. Great. So we have this many technology support, and you can create your own application. So what is the extra benefit of using a JHipster? So one of the main benefits is like everything that we build is a cloud native application. So which means like we provide all the things that is necessary for you to go into the cloud world or cloud native world. So you have this Docker, all the Docker files are generated for your application. And then you have entire list of Kubernetes. You can generate your application and then deploy to Kubernetes with just the application very fast. And that is something that we provide out of the box. Kubernetes, of course, you have to run a separate command. I'll let you know what are the commands. But for now, you have to run the command, configure your Kubernetes, and it provides all the configuration file. It writes all the YAML files, so you need not worry about writing YAML. And apart from that, once you develop your application, you of course need CI/CD pipelines. And we also provide all the CI/CD pipelines that is listed here: Jenkins, Circle CI, GitHub Actions, Azure, GitLab, and Travis CI. All those CI options are provided out of the box. So you can configure your application, push the code into the repository, all the CI will kick in, and everything will run out of the box. And that is very helpful if you want to have complete CI/CD stuff. And finally, we also provide an opportunity for you to upload your code and run in any of the leading cloud providers. So you have something called GA subcommand, with which you can straight away launch app engines in the Google Cloud and run it. Similarly, you also have Azure Spring Boot stuff, which also makes it much more easier for you to launch your application in the cloud. We also have single button click upload for Heroku, and OpenShift generators also available. So you can just go ahead and run your application in your favorite cloud with few commands that are attached to it. And that's what we are providing. That's why I call it as a complete developer platform rather than an application generator, because it provides the entire application along with all the side benefits that you have here. Cool. Any questions? Please let me know if you have any questions. So yeah, so the next step is architecture. So what kind of architecture that JHipster provides? Of course, like there are like thousands of different ways in which you can generate your application. So yeah, the architecture that we provide also has to be slightly opinionated, because we cannot provide all the different architectures. We have different options that you can choose from, but architecture, we have to stringent on this area. So we are providing a limited set of architecture, and also we'll see what kind of architecture the JHipster provides, especially for the microservices. Cool. So you have your main, consider you have an application. So the application is actually built with Spring Boot. You can select something of the client side. For example, you can select React here for the client side. You have Spring Data based stuff for all your JPA stuff, all the database access or done with Spring Data. And then you have Zool. Zool is used for proxying all the requests that is coming through your service. And this entire service, what we call it as microservice gateway. And this microservice gateway is the single entry point for all your clients. So if you want to release your application, if you want to access the application, you have to go through the microservice gateway. So that is an API-based architecture that we are allowing here. And you can have multiple different services, and those services may or may not have databases attached to it. And you can choose to have a database there. You can choose a different database. You're not constrained to choose the same database as your microservice gateway, but you can choose any of those things that you want there. So you can choose any among them. So that is what we call it as microservices. They are smaller application or smaller services that you can run with your application. So on a very high level, that's how your application will look like. And this is much more drilled down version of it. So, so this segment here is your gateway, which is microservices gateway. You have any client based, and then it has a Zool proxy in it. You have a user server here. This can be a JHipster UAA server, which is user authentication and authorization server. or it can be any user servers like OAuth 2 or your own database. And then you have literally any number of microservices that you want to run. And all those microservices on the gateway application connect through a registry. You can choose between a JHipster registry and a console. The console is from HashiCorp, so you can choose between console and JHipster registry, and and all the connections will go through them. And of course, we also provide something called as JHipster console, which is a Docker image, and you can just put it in your application. So what it does is like it has Elasticsearch, Logstash, and Kibana, and it aggregates all the logs, all these stuffs, all the debugging materials that you want to have. It aggregates them together and then show in a single place. And it will be much more helpful if you want to debug any bottleneck stuffs that you have here. So what is the difference between console and JHipster registry? So the main difference in terms of those two service registry, console is actually runs an agent on every microservice that you're running. And what it does is like it provides consistency over availability. On the other hand, JHipster registry provides availability over consistency, which means the application is running on a single node and all the applications will come and connect to that application. So all the application will come and connect to that application. While in terms of console, every application has a chunk of agent which is running, which helps to run the entire application. So what we are going to do today, we will create an application which is nothing but a simple store. So you have a store gateway, a notification service, and an invoice service. We will use a MongoDB for notification service and SQL database for store and invoice service. We create this application. Let's go to the demo. So let's create a folder called Microservices. Can everyone see the screen? Is the font size okay? Just let me know if the font size is not okay. I'll try to maximize it a little bit more. So yeah, so let me create a folder, Microservices. Let me go inside the folder, Microservices. So I have my JHipster installed. So if you want to install your JHipster, it is npm I for install -g generator -JHipster. So this is a command to install JHipster. I have it installed already. So all I have to do is like, let me create another folder, call it a store. Let me go inside the store and then run JHipster, which is a command. So if I run JHipster, what it does is like, it checks whether the application is installed, and then it runs script. Yeah, this is running on the cloud, so there might be a slight delay, but yeah, so you have this JHipster. I currently installed version 6.9.0, which is the latest version that is available. So you can choose between monolith, microservice application, or microservice gateway, or JHipster UAA server. So store is a microservice gateway. So let me select that. We also have a beta version released for Webflux. So if any of you use Spring Webflux, which is a new way of doing reactive applications, we also have support for them. You can choose yes or no here. For now, let me just choose no. And then it asks what is the base name for my application. You can give any name here. Let me just stick with store. And then it asks like what. So it asks me, are you running microservice architecture? What's the port that you have to use? Let me use the default 8080 port. And what is a package name that you want to use? Let me put some package here. And here, the major question is like, what kind of service discovery that you want to use in your application? So you can choose here. You can choose a JHipster registry or a console, or you can omit the entire service discovery part and use tools like Istio to provide service discovery for you. So let's use a JHipster registry here. And authentication, you of course have different authentication mechanisms which we support. we have JWT, we have OAuth-based authentication, and also we have authentication with our own UAA server if you have to use that. So let me just use JWT for this demo. You can choose OAuth. It's also pretty easy to set up. And also you can select a database that you want to select. So you have options here. You can choose an SQL database or MongoDB, Cassandra, Couchbase. As I said, Neo4j is just released. And you can also choose no database if you don't want any database in your application. And after you've chosen SQL database, you can choose a different database for production as well as for development. So for example, I can choose a MariaDB here for production. And also I can choose anything like hash2 or hash2 in memory or disk-based persistence for my development database. Once I've done this, you can add Spring Cache abstraction. So you have an option to choose between EHCache, Caffeine, Hasslecast, Infinispan, Memcache. So let me just use Caffeine here. And it also asks you, do you want to use Hibernate second-level caching? So let's say yes. It also boosts your performance. And a classic question, whether you want to use Maven or Gradle. So Maven or Gradle. So let me use Gradle here. So here you can choose if you want to add an Elasticsearch in your application or WebSocket in your application. You can also use Apache Kafka or API stuff. So you can choose those options if you want to add this to your application. And finally, you can choose any client framework. You have Angular and React. Choose React here and then some theming. You can also add multiple language if you want to. And finally, extra testing options like Gatling, Cucumber, or Protractor. You can choose any one of them. And that's it. And once you've done this, what it does is like it creates all the application files that is mandatory for you to run. And once everything is created, it initializes the Git repository and then runs the npm install over it, and then creates the basic application with all the testing that's required. So let's actually go back to the code here. So we created something here. So yeah, so this is Microservices store. My application is in this particular location, but you can see what it generated. It's a plain simple Java-based application, which is written in Spring Boot, and you have client-side written in React, and that is in TypeScript. So we have this Java folder. This is a basic Spring Boot application, as I said. So it enables Zool proxy since it is your gateway, and it's a Spring Boot application. So yeah, so it runs the application at a given port and all those things. So all the configurations are done with Java files. So all this is extendable. So you can, if you want to configure your customized version on top of whatever we are offering, you can just go ahead and extend these files, and then try to write your own stuff. The reason why I'm saying that you can extend these files in the future, if you want to upgrade to the latest version that we're providing, it would be much more easier for us to upgrade the entire thing, and for you to easily use the application and just change whatever the things that you've customized. So that is something that we provide out of the box. So here, so it has all those things. You have a service layer, and then you have a web layer with the resources and errors and all those things that you want to add it. You would have in your normal Spring Boot application. On the other hand, we also provide a list of Docker files, which makes it easier for you to run your Docker application if you want to run it inside a Docker. So we give an app.yaml, which is nothing but it starts your app. It creates an image. It sends these properties for your app. It runs on this particular port. And then you have your database, which is MariaDB, as we have selected. We also, since we have selected JHipster registry, it also creates a JHipster registry file. So you can start your application, and JHipster registry is also automatically started towards it. You have the Sonar file. You can, all the application comes with Grafana and Prometheus. So you can generate this files. You can run those applications, and all those monitoring stuff comes out of much more easily for you out of the box. And we also use JIT, Java Interface Builder, for running the Docker image. It's much more faster than your normal Docker build. And yeah, on the web app side, it is nothing but a React application. You have everything written in TSX or TypeScript. It's a simple React application with all those things. So yeah, so everything is out of the box that is created for you. Any questions so far? No? Great. Okay, there is a question. Is it possible to create separated projects for backend and frontend on JHipster, or only everything at the same project? Yeah, so you can also choose between backend and frontend. So you can say JHipster. So let me type in the help command here. So you can have multiple different options here. So you can generate just an app. You can omit this. That's what we have run. You can run AWS. So you can run CI/CD for generating those CI/CD file. You can run DockerCompose to generate DockerCompose, and Kubernetes for Kubernetes related stuff. And when you're generating, you can say JHipster -- script client. So what it does is like it kind of strips the entire client generation part. So also you can just have your single application that is generated. Yeah, so that is something that you can do it. And there is so with the skip client flag, you can actually generate only the source side or the backend side of the application. On the other hand, okay, there is another question. Is it possible when generating microservices, is it possible to build the domain during the project generation? Yes, it is possible to build the domain during the project generation. I'll tell you how to do that in just a few seconds. So yeah, so you have generated this application. Your application is ready to go. All you have to do is like run gradle w. See your application running. So let's run it. Let's see how fast it's building. So in the meanwhile, let's go back to the slides. Yeah. So yeah. So we have this. We have this entire source. So as I said, we have that pack for building the backend for the client side of the application. And so as you can see, there is a file called this .org.json, which actually memorizes whatever you have given when you're generating an application. So the JHipster version that you used, what is the type of the application, what is the package name, what are the authentication type that you've chosen. So basically all the options that you have chosen in the step before are stored in this file. So you can use this file in order to generate a new application. So tomorrow, if you have to generate a same application somewhere else, what you can do is like you can just send this file and then ask him to install JHipster and then run JHipster, install this entire stuff. It automatically generates all the application files for you. And that's much more easier for you to share your application to the external world. And of course, since we have selected Gradle, we have this entire Gradle, and the Gradle build is actually structured. So you have this entire Gradle folder, which includes dev version, prod version, sonar, or var generation, or jar generation, and things like that. So for some enterprise client, we still need to do var, but it's basically good to have jar. So jar is out of the box. If you want a var, you can also generate them using this var Gradle. So let's go back. So what happened here is that it tries to install the application. Now it's building Webpack, which is the client side, and then it generates the application. It runs them on port 8080. And also we have an extensive README here, which tells what you have to clearly do in order to run your entire application. And you can also see this entire file in jhipster.tech, the location where we have the entire documentation for the whole set of application. So let's give it a minute. Cool. So let it run. We'll come back to this. We'll go to the next segment of the presentation. So yeah, we have generated a JHipster simple microservices gateway application. So let's go back and see how we can make this generation much more easier. So we can make this generation very much easier with the help of a thing called JDL. So what is a JDL? JDL is nothing but JHipster domain language, and it is a special way for you to create your application much more simpler, and also create your application and entities grouped together as a single file. So it would be very difficult for you to run different application and then generate, like, suppose you have 5 to 6 microservices, you have to go through this entire JHipster stuff again and again, enter some value, and if you mistype some value, then you have to cancel it and come back and enter. Not to lose, make it easier for you to generate an application, what we have is JDL. Let's go and see how a JDL will look like. So I have a folder here. So if you take a look at here, so this is a JDL. So a JDL is nothing but a single entry file where you can put all the things that that is required for you to generate an application, and then run those applications straight away, and then generate those applications straight away. So for example, you have application here. So inside this application tag, you can specify the list of the configurations that are needed. So here it's again the same stuff: the base name of the application, the type of the application, which is gateway here, and the package name. If you want to add a service discovery, what kind of things that you have had, authentication type, or the production database, cache provider, build tool, client framework, and all those things. So there are some options are missing here. Suppose, for example, if you remove giving build tool here, what it means is like it takes the default option, which is Maven. So you can give that thing here. So let me just go and use Gradle here. And also, if you're using Visual Studio Code, we have something called as JDL extension, JHipster JDL extension. That kind of helps you to, write this JDL files and also validate the JDL files when and as and when needed. So that will be really helpful for you if you want to run the JDL stuff in your VS Code stuff. And you can tag entities to an application using the entities keyword. So here, what I'm doing is like entities followed by star, through which means like I tag all the entities that I have in this file to this application. So all the entities will be generated together with the application. And for example, I have another smaller application, which is the invoice microservice. So base name is invoice, and as you see, it's a normal microservice. It is not a microservice gateway, just a microservice, which means I will not have a client side here. And it uses same authentication. It uses a MySQL database, same build tool. And also here, I'm skipping the user management. So your microservice need not have a user management. Only your base application should have the user management. So here, you don't use the user management here. So I just skipped it. And also here, I'm saying like, okay, so entities, just use invoice and shipment. So here we have said, choose all the entities, but here we can also specify a specific set of entities. I mean, like just use invoice and shipment entity for this application. And similarly, I have the third application, which is the notification. It is also microservice. But the difference is I'm using a MongoDB here, and it just uses entity notification. So if I drill down further, so I have this entity product. So how do you define? Entity is a keyword followed by the name, which is capitalized, the first letter. And then you have the list of table columns. So I have the name followed by the type of the column, and then followed by some validations. So it is like, for example, here for the price, it's a big decimal. It is required field, and the minimum value should be 0. And I can also say maximum value should be something like this. So it is also possible to define it here. So I can also give a regex pattern here to match that it follows the regex pattern. And one of the important things is like I can also have the custom stuff here, just like this size, which is an enum that is defined here. That enum has small, medium, large, XL, and all those things. And then I have something called as product category. A customer is defined here. The gender, which is an enum that is used here. And so once you've defined enum and your entities, the other obvious thing that you have to do is like how do you define your relationship? So what we have is like relationship followed by the keyword one-to-one, many-to-one, or one-to-many, or many-to-one, or other options that you want to have. And then here you can define it, like you can say like customer user login, this is a required field to the user, or many-to-one order item, product name required to the product. So you can define that kind of relationship among the entities that you have, which makes it much more easier to develop your application. And finally, when you're developing a service, when you're actually creating those entities, you also want to create service for them. You can say like whether you want to create those service, just a service file, or with an implementation. So it generates an interface service and an implementation. So the keyword is service with implementation. So you can use this, or you can just use service class. So whichever that makes sense for you. So whichever the technology or whichever the architecture that you want to follow. So you can either use with service implementation or with service class. And then you can also add a pagination support, which means it also adds a pagination view on the front end, as well as on the back end. What it does is like it creates paginated entities, and which makes it easier and also robust for you to run your application. And then you have this your microservices related entities like invoice status, and those things. And you can also specify all those things. Here, this line is required to state that microservice invoice will have these two entities attached to it. So you have to define it at two different places. We are working on it. We'll try to remove that dependency in the future. But for now, you have to do it in two different places. Similarly, for notification, you have these two things. Yeah, so you have this entire entity defined here. Your application is defined here. So let's go back here. Oops, something has happened. Okay. So yeah, so here let's go back to the application. Let's go to 8080. So as you can see here, the application is getting started. It's of course running on the cloud, and it's a development build. It might be slower, but you can see I can log into the application, admin. It creates, it has nothing inside. It's just an application with, it's a gateway, and it doesn't have any of the servers that are attached to it. You can see the metrics of the application. It says like, what are the JVM metrics? What are the threads? How the garbage collection looks like? How many requests are going? Since I've logged in as an admin, I can see all those things. All the endpoints that I have, how many requests that went through it, and what are the cache statistics that I have. And health of the application, you can change the configuration, you can configure the logs. Since I've used database, you can also click on this database stores. It also creates all the database that is required for you, all the tables that is required for you. So let's go back, stop this application, clear the table, and then let's go back to the microservices. Let me check the folder name again. The store app. Yeah, so I have this app.jdl here. So all I have to do is like JHipster import -jdl followed by app.jdl. Yeah, so what we'll do is like it will create all the application. As you see here, it finds out that we have 3 applications, so it creates them in parallel. So you have the store application, the invoice application, and the notification application. All of them will run together. So it generates all the necessary files. So if you go back to your folder structure, you can see here. So you can see here you have the store, which is where your entire application will run, which is where your microservice gateway lives in. And you have the notification. As you can see here, it's also a simple Spring Boot-based application with all the pre-configured files that you need to have, but it doesn't have any web app or web-related stuff, which means no client side for this application. And then you have this invoice service. So you can see in the notification, you also have a Docker file, and that creates MongoDB. You can also run it in cluster-based or a simple MongoDB. But again, running those 3 different applications at the different places will also makes it quite messier for you to run the entire set of application, right? Because you have 3 different applications, you have to go and start those applications, stop those applications, which makes it much more complex for you to run the entire set of application. So we wanted to make it easier for you to do it. We want to make it easier for you to generate all these applications together and run them with a single command. And what we have is called as DockerCompose. So DockerCompose allows you to run multiple services together. So what we provide out of the box is like not out of the box with a command to generate your application. So let's cancel this thing. I have an application that is already generated. Let's go back there. So so as you can see, the application is generated. So I can also create a folder called as DockerCompose. And inside the DockerCompose, what I can do is like, I can run JHipster docker-compose. So what it does is like, it checks whether the Docker is installed in the machine. So once it verifies the Docker is installed, it asks you a bunch of questions similar to before. So here, it asks whether you want to use a monolith or microservice. Let me use a microservice there. And then it asks what kind of gateway that I have in my application. So I can use JHipster gateway. And then it says like, what is the root directory in which you have to run your entire set of application, or where is your application present. So I can choose this one. I can choose all the applications that I have. And then it also finds out that I have MongoDB entered for one of the applications. So I can choose whether I want to use a cluster database. Let me not use here. And then it asks like, do I have to add JHipster console? For now, no. Let's just run plainly. And an admin password for JHipster registry, which is the service registry that we're going to run. So as you can see here, it generates all the Docker related files for you to run your application as a single app. And it also specifies, looks like you don't have a production build of the application, or the Docker image is missing. So generate the Docker image with those commands. So all I have to do now is generate the Docker image with this command and use that stuff to run the entire application. So let me go a couple of steps back and then use the pre-demo application. So as you can see here, it's the exact same composition. You have compose, invoice, notification, store. And the only difference is like, I have run all this production build. So I don't have to spend much time here to do this production build. So let me show you the generated files. This is the microservices demo, and this is the exact same application serves. All those things are similar, and this is how my DockerCompose file looks like. So as you can see, I have an invoice which takes an invoice image, and it's attached to a MySQL database. It takes that value. Similarly, a notification for notification and notification MongoDB, and then a store MySQL, and then it also extends the registry. So it does all those things, accumulates them together. So all I have to do now is all I have to run is DockerCompose up. And what it does is like, it creates all those things that is necessary. So it composes all those things together. It boots up all the applications together. It runs all the necessary servers, all those things. And all I have to do, wait for a few minutes. It generates all those things, and you can just go ahead and see what is happening inside the application. And that's basically it. So have a single command, which is DockerCompose up, and that command will help you to run all the applications together, which makes it much more easier. So I have my JHipster registry up and running. So let's go to the folder. Let's go here. JHipster registry actually runs on 8761, which is also, again, a JHipster application. JHipster-based application, but it's used for finding out how your application works. It acts as a service registry. So you can see here, none of the instances are started yet, but the config server is up. The disk space has no problem. It also shows all the available memories and all the general info. So it's a single stop for all the administration stuff that you want to do. Excuse me for a minute. Yep. So you have different metrics here. So only JHipster registry is up at this moment. So it waits till the other applications are booted up. So let's see what's happening here. Okay, it's running. Yeah. So I have one of the services is running here. So notification is booted up. So let's refresh now. Oh, all the services are booted up here. So you have invoice, notification, and store. All those things are running together. You can see You can also see the health of those different applications. You can choose like, okay, so how my invoice is doing, or okay, it's booting up. So how my notification is doing, how my store is doing, and all those things. And you can also see the metrics of different applications. So it shows the invoice metrics specific to invoice, and then specific to notification, and all those things. You can also check the logs of the application. This is one of my favorite feature, because if you want to see what is happening to your application, you can just go and see it here. This actually splits a log based on the application, so you can check what is happening for your application, how you can store all those things. So yeah, so you have everything is running. So what you can do is like you can just run 8080. So your application runs on 8080. So if you can check this, your application is booted up. So you can sign into your application, admin. So the only difference here is like all the entities are generated than what we seen in the previous scenario where there were no entities. But the entities also create a basic CRUD operation screen. So you can just go and create anything here. For example, a t-shirt, and you can price it whatever you want, can size it whatever you want. So you need a product category here. So let me save it. It's saved it's a product category because that is not an essential field. But you can create a new product category here. Shirt that you can wear. So it creates all those things. Now we can go back to the product and then edit it, and then so yeah. So this is how, and then here from here you can click. It shows the product category, so you can do all those stuff here. You have this gateway management here through which your store gateway can understand what are the servers that it has been connected to, what are the profiles that it is running, what is the port in which it's running, and what is the version of the application, which is very useful in a microservice as well. And you have a simple set of users, system, admin, and user. And then you have metrics. Here also you can see the metrics, but the difference between JHipster registry and here, in JHipster registry, you can actually see the metrics of all the applications that is connected. So for example, it shows all the applications, JHipster registry, invoice, notification, and store. Here, it just shows the application in which you're logged in. And then you can also see the logs. This is a more or less the logger configuration. So you can dynamically change the log to trace or debug or information and do that. And since we also integrated with Swagger API, it gives you the complete list of APIs that are available. So you can use the API account, API change password, activate, authenticate. You can also use customer resource, gateway resource, order item resource, product category. So it gives you this in detailed version of your API management and what a user can expect. So if you have to release this to the external world, you just release this endpoint to them. It is a documented value, and then it shows like you can split it based on the application and all those things that you have. And of course, since we have seen internationalization, I18N, you can also choose different language. We also have support for them. So the application is now in French, but you can also choose like there are like 30 to 40 languages that we support. You can choose between them. And then you have an account here. So here also invoice, it's a straight way of creating an invoice. You can create an invoice, something like invoice 1. Again, you're creating an invoice for the application. Test invoice. And the status is issue, cash on delivery, something like 252, save. So now you're actually connecting, you're actually requesting an 8080 port, but it goes to 8082, which is where your invoice is running, and then persisted the data inside there, and then fetches the data and comes back. So yeah, this is the original microservice example. That's basically it. So you can see all the instances registered here. So yeah, so that's how JHipster makes it much more easier to generate an application, microservices application. And so let's go back to the what you have seen so far is like the microservices, the architecture that we are building, and how you can use JDL to create your application much more simpler. So that's it from my side. If you have any questions, yeah, let me know. It's time for the questions. So there are a bunch of questions. Do we have sample applications with different configurations? Yes, there is a lot of samples available. For example, let me go back here. First thing is like JDL samples. So here you can see a bunch of samples that are available. We also find newer ways of creating samples. And if you have any nice ideas to create samples, you can also go and create a pull request here. We have a bunch of samples here through which you can create your application and check how it is working. And if you don't want to install the generator and you just have to work or see how the application behaves, we also have something called a sample. So you can use the sample application and then just clone this into a zip file and then try to run it in your local. And it also has all the latest stuff that you want to play with. So that is basically it. What's the next question that we have here? Is it possible to provide navigability to your services with JHipster like HOS? That's a very good one. We don't have that possibility at this moment, but it's something really cool to add to the application. We're actually brainstorming something for version 7. And if you have any nice idea around that, just let us know. We can also try to provide it. Is there any authorizations we can provide in registry based on roles? Is there any authorizations we can provide in registry based on roles? Right now, the registry itself is a JHipster application, but we don't have users here, which means like it's only applicable for one person, but we don't have that granular control for the registry. So if you want to have that much granular control, I would say console is very good at it. You can provide a console, but JHipster registry plain out of the box, we don't have any configurations for an user available. Cool. Is there any question? Any more questions? Yep. So you can also reach me at any of those channels, in Twitter or GitHub or Dev, and then you can also reach out to the JHipster team if you have any questions. We are happy to help, and if you have any cool features, just let us know. Thank you very much for the time. Oh, sorry, we have a question here. Does JHipster generate unit tests? Of course, we generate unit tests. Let me go back. So all the things that we're generating has test attached to it. It doesn't matter what you're generating. So here you have test for all those things. We have this entire, you have an architecture-based test. And also you have JUnit test for all the restores, integration test for all the restores, servers and security and all those things. So completely tested. We have around 70% of test coverage for all the code that we generated. And also we have end-to-end test for JavaScript, and also speculation test, which is the unit test specs we have. So we also cover it 100%. We also try to cover it most of the cases that we want to do it. Yes, and we do have tests for them. Cool. Oh. Okay, there is one more question. If I have an enterprise config or repository server, how can I config this? Yeah, under the hood, everything that we have generated is a plain Spring Boot based application. And if you just have one single configuration, or if you want to change the configuration, I'd say like you can just go ahead and change the data configuration that you have here. So the domain configuration and the Spring database configuration. And if that is what you're trying to ask, yes, you can change. You can add your extra configurations because all this config that you're generating is a Java file. You can extend them and modify them. And then once you have it as a separate file, it also makes it easier for you to upgrade. But apart from that, yes, that's basically what you can provide. Yes. Cool. Okay, let's wait for Daniel to join. Meanwhile. No, we don't have support for GraalVM at this moment. So yeah, there is another question. Does it support GraalVM as well? I think no, we don't have support for GraalVM at this moment. We have Kotlin or Node.js, and also there is some upcoming work on Go, but we don't have anything for GraalVM. Cool. Again, thank you. Bye bye, everyone. Have a good day. Stay safe.